Hi, ladies and gentlemen. Today we're going to talk about interpreting graphs of functions. So in your notes, please write the title at the top and get ready. First, we have the skills that we're working on today. We're going to be working on, for a function that models a relationship between two quantities, we're going to interpret key features of graphs and tables and sketch graphs showing key features when given descriptions. To do that, we're going to work on the math practice of making sense of problems and persevering in solving them. So first we have some vocab. Our first term is the word intercept. And an intercept is the point at which a line or curve crosses an axis. An intercept is really where a point or the point at which a line or curve crosses any other point. But what we care about is when it crosses the x-axis or the y-axis. So we're going to talk about the x-intercept and the y-intercept. We're also going to talk about line symmetry. A graph has line symmetry if the graph can be folded over the y-axis or some other vertical line and match exactly. So what we're talking about with our symmetry is we're talking about vertical line symmetry. Some key ideas: when we're interpreting graphs, we want to talk about whether it is positive or negative, and that tells us in relation to the x-axis. Are we above the x-axis, in which case we are positive? Are we below the x-axis, in which case we're negative? So we're talking about our range values. Is the range positive or negative? Now we're also going to talk about increasing or decreasing. If I'm looking at my graph, as I move from left to right, do my values go up or do they go down? We're also going to talk about end behavior, so the values of the function at the extremes, the positive and negative extremes. So to do that, first we're going to look at this diagram, which explains those terms and has some pictures. So as I said before, we're talking about positive and negative. So whether it is in relation to the x-axis. So we have our positive sections in blue here, and we have the negative sections in red. You do not need to write down the information on this slide. I think it's just a good way to put a visual representation of those words that we just defined. Increasing and decreasing. So as we're moving from left to right, is our slope negative or positive? If we have slope going downhill, we have decreasing sections. If we have slope going uphill, like we do here, as we move from left to right, this section is increasing. The one part we didn't write down in our notes, because I think it's pretty self-explanatory, is the idea of extrema, so extremes of behavior. When we're looking here, we have a relative minimum. If I look at this point A, there are no other values lower than it in close distance. This over here, I can see it looks like it's extending to negative infinity, but this is a relative minimum. Same thing with B. I have a relative maximum, even though I have higher range values over here, but I have a relative maximum. The end behavior tells me about the ends of the graph. So if I look at the extent of what I have on the graph in front of me, I can see that this part here, as you move left, so as the graph goes up, as x decreases, y is increasing. And then you have the opposite end behavior on the other end. So let's practice with this here. The first one, and this looks a lot like your homework, just different examples. The graph shows a function that approximates the shape of the gateway arch, where x is the distance from the center point in feet and y is the height in feet. Identify the function as linear or nonlinear, then estimate and interpret the intercepts, and describe and interpret any symmetry. So the first thing I'm going to do is I need to identify, is this linear or nonlinear? Can I represent this with a straight line, or is it not a straight line? Well, it's a curve. It's not a line, so this is a nonlinear function. So in your notes, you need to write a sketch of this graph, and you need to have the term nonlinear. You can do this as bullet points. You don't need to write it out in sentences like I have here. The next piece asks us to think about the intercepts. So first, I see a y-intercept. I'm going to estimate the value here. So these markings are every 80 feet. So I can estimate that that y-intercept is about 0,640. So what I can write in my notes is just y-intercept. And if I have that wiggly equal sign, that tells me approximately 640 feet. What that means is the height of the arch is 640 feet at the center point. That's that part about interpreting the intercept. So that y-intercept 640, and that tells me height, H-E-I, of arch. So next thing I need to do is I need to look for those x-intercepts, and I can estimate that it looks like it'll cross the x-axis here and here. Again, those are spaced out 80 feet apart. So my x-intercepts are at about negative 320 and positive 320. My interpretation of those values is that means that the arch touches the ground 320 feet to the left and the right of the center point. If I dropped a pin from the top of the arch down to the bottom, 320 feet from each piece. So in your notes, bullet point, you should have x-intercepts written down and the interpretation that is telling me the width of my arch. Now I need to think about the symmetry. So if I look at the symmetry of this graph, I see that the right half of the graph is a mirror image of the left half over the y-axis. So my line of symmetry would be that y-axis. In the context of this situation, that tells me that the arch is symmetrical. The height of the arch at any distance to the right of the center is the same as its height to the same distance to the left. So in your notes, what you need to have is that it's symmetrical along the y-axis, and that tells you that it's symmetrical. Those are the big ideas to write down in your notes. One more practice problem. You're going to sketch the graph in your notes. This time we're talking about the H1N1 virus, and I think this data comes from that 2009 outbreak of the swine flu, which is H1N1. The H1N1 virus can be modeled by the function graphed below. Estimate and interpret where the function is positive, negative, increasing, decreasing, and the x-coordinates of any relative extrema and the end behavior of the graph. So this one I'm asking to identify different pieces than I was on that first graph. Well, first I want to know about where it is positive and where it is negative. And I can see that my graph is positive for all values of x between 0 and 42. So for all values shown, it is positive, and for all values shown, it is not negative. So what that tells me, the real world interpretation of that, is that the number of reported cases was always positive, which makes sense. We can't report a negative number of cases. We're always increasing our value of reported cases. Now I want to think about increasing or decreasing. And again, for all values shown, we are increasing. We are not decreasing in any segment on the graph, which tells me my real world interpretation is that the number of reported cases increased each day from the first day of the outbreak. This doesn't include that whole idea of recovered cases that we talk about now with our current pandemic. Now I want to think about the x-coordinates of any relative extrema and the end behavior. So for my relative extrema, I see a relative maximum at about x equals 42. So the highest point on this graph here is my last point shown, and the relative minimum is that first point shown at about x equals 0. The extrema tell me that the outbreak started with 0 cases at day 0, and the number of cases peaked at about day 42. For my end behavior then, I can see that as x was increasing over time, the y appeared to level off. We are approaching a slope of 0 as we get to this top section of the graph, which indicates that we have maxed out at about 11,000 cases here. We're going to estimate that value. So my end behavior is that the slope was approaching 0 at day 42 with a maximum of approximately 11,000 cases. So that's it for your notes. In your notes, you should have bullet points for each of these ideas and a sketch of the graph. And your homework is going to be a worksheet. Your worksheet has 4 different problems, very similar to the practice problems we did. What you will do is in your notebook, you need to make a sketch of each graph, and then in words, identify the key features, just like our note-taking activity. If you check on Teams, I've now created a different type of assignment where you are actually going to take a picture and upload that picture of your homework page. Because this one has too many possible correct answers, I want to be able to check your work on this one rather than asking you to correct it. So you'll open up the assignment on Teams, the PDF is attached, and then you will upload a picture of your assignment when you're finished. Thanks, guys. Keep working.